Okay, hi guys. This is Mrs. Ortega, and we're going to be reviewing lesson 4 in geometry, and that's the postulates and theorems about points, lines, and planes lesson. So exciting stuff. So let's just we don't actually have too many examples. We have a few to go over, and not too many notes either. So I'm just gonna go over a couple of postulates and with you. I'm not going to write them down like I did before, so I'm just going to explain them. So we're going to start with postulate number 5, which is which says that through any 2 points, there is exactly one line. So any 2 points, there's only one line that can go through them. Pretty easy, not that complicated. Here's another one. So if you have 2 points, any 2 points, there is only one line that goes through them. Pretty easy stuff, right? Okay, so next we're going to go over some theorems. And what are theorems? Theorems are simply theories that must be proven to be accepted as true, unlike postulates that are generally accepted without having to be proven. So theorem number 1, or 4-1, says that if 2 lines intersect, so let's just draw an intersecting line here. If 2 lines intersect, they intersect at exactly 1 point. Only one. Okay, so that's all the theorem says. So let's go ahead and look at example 1. And example 1 is basically just, okay, I don't have my other tools here, but example 1 basically just has this drawing on it, and it just says, does this diagram show 2 distinct lines through point A and B? Points A and B. So it says use postulate 5 and theorem 4-1 in your answer. So remember, postulate 5 says any 2 points has exactly one line that goes through them. And postulate 4.1 says if 2 lines intersect, they intersect at exactly 1 point. So the problem here is they're trying to show that it actually intersects at 2 points. However, as you may have guessed, this isn't actually a line because it's actually curved, right? So because it's curved, it doesn't actually, it is not a straight line. It's not a line. Therefore it can't be, it's not straight, therefore it can't be a line. So so for that example, it actually still proves postulate 5 and theorem 4-1 because this curve is not a line. Okay. All right. So postulate number 6. Postulate number 6 says through any 3 non-collinear points, and non-collinear again means they're not on the same line. So through any 3 non-collinear points, there exists exactly one plane. So here we have 3 non-collinear points on one plane. Okay, pretty simple postulate. Theorem 4-2 that kind of goes along with this says if there is a line and a point not on the line, then exactly one plane contains them. So how does that look? So that looks like, well, we could join any of these points together to make a line. So again, the theorem says if there is a line right here and a point not on the line, then exactly one plane contains them. Okay, that's all the theorem says, and I'm just demonstrating it to you visually. All right, so let's go move on to theorem 4-3. Says if 2 lines intersect, then there exists exactly one plane that contains them. If 2 lines intersect, then there is exactly one plane that contains them. So I could actually just put these 2 together. They are intersecting lines. Okay, and all it's saying is that the two lines have one plane. Because they intersect, only one plane can contain them. So let's go ahead and look at examples 2. Okay, and that's so that we can put some of these theorems into place. All right, so this is kind of a complicated drawing here, so I'm going to just show it to you on the video. So can you check to make sure it's accurate, please? All right, so
zoom in.
Well, just make sure it's okay.
Yeah.
All right, so here we have example number 2, and it says, see, I didn't want to draw this whole thing. It says identify the following items in this drawing here. So 4 points. So can we identify 4 points on here? There's actually exactly 4 points, so I think we can. And that is point A, point B, point C, and point D. Identify 2 lines, and there's exactly 2 lines on here, which is line AB and line CD. And identify 2 planes, and here we have plane N and plane M. Okay, so I hope that was pretty easy. The next item, what was that? The next thing we want to go over is postulate 7, which simply states if 2 planes intersect, then their intersection is a line. Okay, so I kind of drew it, but let me see if I can draw it on here. If 2 planes intersect, then their intersection is a line. I actually like the way it's drawn on the page a little bit better. So here we have postulate 7. Bella, can we see this? Okay.
Yes, you can see it just fine.
Okay. So here we have postulate 7, and you see the 2 planes, plane M and plane N right here, and you see the intersecting line AB right here. So they intersect at exactly 1 line, AB, no other place. All right, so that's all that postulate 7. So let's go ahead and look at example 3, which actually is right on, is probably better seen in the book. Okay, and example 3, because it's so busy, I wanted to go over it with you guys.
Can you tell me what page it's on?
It's on page 23.
So if you can't see it, just look on page 23.
All right, so identify the intersections of plane M and N. So what is the intersection of plane M, which is right here, and plane N, which is right here? Remember, 2 planes intersect, it's going to be a line. The only line I see here that intersects both of these is right here, GH. Okay, so that would be the intersecting line. And the second part of this example is identify all points of intersections of lines on plane M. There's a few of them. We see GH is a line, and it intersects FE right at point P right here, and it also intersects this point right here, this line CD. Okay, so there's line GH has 2 points of intersections, point P and point, I guess this is Q, because this is line D. Okay, so the other 2 lines that intersect are are lines FE and lines CD, and they intersect at S. Okay, so that's about it for that example. Okay, so now let's look at postulate 8. Okay, a couple more to go and we are done. I'm actually timing myself to make sure I finish before 10 minutes, and I don't know where I'm at. I'm at, oops, I have 30 seconds left. Okay, so postulate 8 says, if 2 points lie on a plane, then the line containing the points lies on the plane. If 2 points lie on a plane, so let's do a plane. 2 points lie on a plane, That's an ugly plane. Sorry about that. Then the line containing the points lies on the plane. So yeah, so this is the 2 points, and if we draw a line through it, then the line has to be on the plane. So that's postulate 8. Postulate 9 says a line containing at least 2 points. A line contains at least 2 points. A plane contains at least 3 non-collinear points, which I think we've learned before, but let's just, draw this out again. So remember, a plane is 3 non-collinear points. Okay, 3 non-collinear points. A line contains at least 2 points. A plane contains at least 3 non-collinear points. Space contains at least 4 non-collinear points. Okay, so space has 4 non-collinear points. So that's it. That's the postulate, and that's all I have for you guys for lesson 4. So we're pretty much done, and I hope you guys are able to get through the lesson. Okay, if you have any problems, let me know in the comment section, and I'll try to help you guys out. I hope this helps.